Okay, so today we are doing multiplying. Multiplying has very similar rules to multiplying when you have variables. Okay? You are going to multiply what's inside the radicals together, and you're going to multiply what's outside the radicals together. Okay? Outside times outside, and inside times inside. Once you get an answer, we're then going to also see if we can simplify our radical. That's why we did simplifying first. Okay? So, just like last class, what's step one always anytime we have a radical? Type it in the calculator. Sometimes this looks ugly, and then I type it in the calculator, and it's going to spit out a nice, pretty number. So you always start with the calculator. Square root 5 times square root 30. So we're all typing it in the calculator with me. Again, I'm not doing it for my benefit. Let's go. And we get a yucky decimal. Okay? Both the 5 and the 30 are under the radical. Is there any number outside the radical?
Well,
no.
I just did 1, but no.
So what's 5 times 30? What? 150. 5 times 30 is 150. Okay? Now, the tricky part, guys, if I typed in the square root of 150 in my calculator, do I get an equivalent decimal? Yes, but that's not my answer. Okay, the reason that's not my answer is 150 is a pretty big even number. Do you think it's divisible by a perfect square? And if we don't know, always check.
Oh, I think I know.
150 divided by x. Let's all check on our calculator.
Oh, really get that? Sorry.
150 divided by x. Go to your table. 1 and 150, neither on the list. 2 and 75, neither on the list. 3 and 50, neither on the list. 4 gives you a decimal, skip it. 5 and 30, neither on the list. 6 and 25. 25 is on my perfect square list right here. I am looking for perfect squares that my radical is divisible by.
Don't open this because it's all different.
Okay, so I'm going to rewrite my square root of 150 as what? Square root 25, square root 6. Very good. Remember, always put the perfect square before the non-perfect square. Okay? Well, what is the square root of 25?
5.
5. Is 6 divisible by any perfect squares?
No.
Nope. Square root 6. What should we do now? Check it on our calculator. 5 square root 6. And we get an equivalent decimal. What makes this answer a better answer than this answer?
To simplify?
I simplified the radical. You must simplify the radical. Just if you multiply correctly, that's only half of the problem. You have to also then make sure that you simplify the radical. There's my answer. Okay? Next one. Again, always start with the calculator. Are we all typing this in our calculator? You need practice on typing it in the calculator. And we get a decimal. So I'm just going to multiply the numbers. Are there any numbers outside the radical? No, so I don't have a number outside the radical. There's no coefficient. What's 14 times 2? 28. So I am turning all of these multiplication problems into problems we did last class. Go to y equals and do 28 divided by x. Go to your table. 1 and 28, not on the list. 2 and 14, not on the list. Skip 3, you get a decimal. 4 and 7, 4 is a perfect square. What is 4 paired with?
7.
7 is what kind of number?
Alright.
Prime, so I know that 4 and 7 is my good pair to pick.
How do we know that with the prime number?
Because if you have a radical, if one of the numbers that you're looking at on the table, if one of them is prime, you know it doesn't simplify.
Alright,
So you know that's the good pair to pick.
Okay.
Okay? Well, what is the square root of 4?
2.
So 2 square root 7. What should we do now? Check on your calculator. Guys, again, I am not helping you at all on your quiz next class. I am not helping you at all. None of them are multiple choice. They are all free response. Check in your calculator. And I get an equivalent decimal. The decimals are the same. So I typed in my original, type in your answer, and they always should be equivalent values. Now, just because they're equivalent doesn't mean your answer is right, because I also could type in this square root of 28, and I get an equivalent answer. But the square root of 28 is not my correct answer because it's not simplified. So just because they give you equivalent decimals doesn't mean that's necessarily the correct answer. It just means that that's not like 100% wrong. Okay, it's an equivalent value. That's why I'm saying you need to make sure that the radical is fully simplified. 28 is a pretty big even number, so that's why I went and did 28 divided by x on my table, or on my y equals, and pulled up the table to see if it's divisible by any of my factor pairs, my perfect squares.
What were you saying? That we have to make sure that it's...
Make sure you simplify it.
Okay.
That's it. So it is simplified. There is my answer. Okay, I want y'all to do number 3 on your own. Do number 3 on your own, please. So, like always, start with your calculator. Square root 21 times square root 3, I get a decimal. So I can't just type it in the calculator and get an answer. Both of these numbers are under the radical, so square root 63. 21 times 3 is 63. Go to y equals and do 63 divided by x. 1 and 63, not on the list. Skip because it's a decimal. 3 and 21, neither on the list. Skip, skip, skip because those are all decimals. 9 and 7. 9 is on my list. And 9 is paired with 7, which 7 is prime, so I know I can't simplify further. What's the square root of 9? 3, so 3 square root 7. I can then check in the calculator again to make sure that these are equivalent to each other. And they are. Okay? Walked around, I saw lots of good answers. We good with those? Yes? Okay, what do we notice about the next row that's slightly different?
They have the numbers outside the radicals.
There's a coefficient. You have a number out in front of the radical. Still, what is step 1?
Just put it in the...
Put it in the calculator.
Yeah.
2 root 15 times root 3. Yucky decimal. Okay? So, if I have coefficients, you're going to multiply the coefficients. But here, what's the only coefficient I have outside? So 2 is the only coefficient. There's nothing to multiply 2 by. This radical doesn't have a coefficient out in front. Okay? We good with that? 15 times 3 is 45. Notice how I keep it under the radical. Okay? When I go to y equals, what am I going to type in?
45.
I don't mess with the 2 at all, do I? Just the number under the radical divided by x. Go to the table. 1 and 45, no decimal. 3 and 15, not on my perfect square list. Decimal. 5 and 9. 9 is on my perfect square list. Okay, again, looking for perfect squares that are on my table. So I'm going to rewrite this as 2 square root 9 square root 5. 5 is prime, so I know that 9 must be the largest perfect square that 45 is divisible by. Drop your 2 down. What's the square root of 9, guys? 3. Square root 5. And then what is 2 times 3? So this is 6. Square root 5. What should I do now? Check on the calculator. 6 square root 5. Do my decimals match? Yep. There's my answer. So remember, insides times insides, outside times outsides. Okay? Next one, start with the calculator. 4 square root 2 times 2 square root 6. And I get a decimal. Outside times outside. 8. Inside times inside. So 8 square root 12. So I'm going to go to my calculator and I'm going to do 12 divided by x. Pull up the table. 1 and 12, not on my list. 2 and 6, not on my list. 3 and 4, 4 is on my list. So I'm going to rewrite this as 8 square root 4 square root 3. 8, what is the square root of 4, guys? 2. Square root 3. So what's 8 times 2? 16. Square root 3. Go to your calculator. And we get equivalent decimals. Also, not only because I have equivalent decimals is this my correct answer. What else makes this my answer? What has to be true?
Where is the prime number?
The radical
Yes, the radical.
cannot be divided by any perfect square. 3 is prime, so I know this is fully simplified. Good? Can we do number 6 on our own? Do it. Okay, let's go over this one. I'm going to skip some of the steps because y'all already did it yourself. So you type it in the calculator, you get a decimal. So we got to work it out by hand. 5 times 3 is 15. 8 times 6 is 48. You then go to your calculator and do 48 divided by x, and we know that 48 can be split up into 16 and 3. I saw a couple of y'all, like 3 or 4 of y'all, break it up into 4 and 12. Okay? Yes, 48 is divisible by 4 and 12. 4 is a perfect square. But you want the largest perfect square, so that's why I chose 16 and 3 instead of 4 and 12. 16 is larger than 4. Okay? Drop down your 15. Square root of 16 is 4. Square root of 3. Also, I saw probably 2 or 3 of y'all write 19 square root of 3. If you already have a coefficient out and you're taking a number out of the radical, you are multiplying them. So 15 times 4 is 60 root 3. And then you would type that in the calculator again, and you get the same decimal as we started with. Also, it is fully simplified because 3 is not divisible by any perfect square on the board. Okay? How do we feel about those? Good? Inside times inside, outside times outside. Okay? Now we're going to do somewhere we have to distribute. How do you know you have to distribute? Parentheses, and what's inside the parentheses? More than one term. Okay? How do you know you have more than one term?
The plus sign.
The plus sign. Okay, we still start with the calculator. 2 Root 2. I should not be the only one doing this. Type it in the calculator exactly as you see it. Exactly as you see it. And we get a yucky decimal. We have to do this by hand. Okay, what's glued to the print?
What did you get for the
52.089.
Okay, yeah.
What is glued to the parentheses? Is it just square root of 2? 2 square root of 2. 2 square root of 2 is one term because it's all glued together. So I'm going to take this whole 2 root 2 and distribute it to my 3 root 2. So I'm going to do 2 root 2 times 3 root 20. I might have said 3 root 2 the first time, sorry. Okay, take your outside term, distribute it to the first term in the parentheses. 2 root 2 times 3 root 20. Then I'm going to distribute my 2 root 2 to my positive 5. What's a positive times a positive? Positive. So plus 2 root 2 times 5. Remember, when you distribute, what operation are you doing?
Multiplication.
Multiplication. Great job. Are we good with that? So now in this problem, we are following our multiplication rules that we just learned, but we're also going to have to follow our addition rules that we learned last class. What I'm going to do is I'm going to pretend this second piece isn't even there, and I'm just going to worry about the 2 root 2 times 3 root 20. Okay? So, outside times outside.
The 2 and the square root 2 is still glued together, right?
It's glued together. There's no plus or minus sign in between the 2 and the root 2 to separate it. So what's 2 times 3?
I just got confused saying that there's a
6. And then root 2 times root 20, root 40. Let's keep simplifying this. Again, I'm going to pretend this part's not even there. Let's just keep simplifying like we were doing up top. I'm going to go to my calculator, I'm going to go to y equals, and I'm going to do 40 divided by x. One and 40, not on my list. 2 and 20, not on my list. Skip, because it's a decimal. 4 and 10. 4 is on my list. What are factors of 10?
5.
5. Is 5 on my list?
No.
No, what else? 2 is 2 on my list? No, what else? 1 and 10, right? Are either of those on my list? No, so that's how I know this is the correct factor pair. 10 is not divisible by any perfect square. Okay? So I have my 6, and I'm going to break my 40 up into root 4, root 10. Root 4, root 10. Make sure we're doing this with me, guys. This is putting a lot of what we've done the last 2 days together. What is the square root of 4? Root 10. And again, I know root 10 cannot be simplified because it's not divisible by any perfect square. What's 6 times 2? So 12 root 10. Are we good with that part? Okay, now I'm going to pretend this isn't here, and I'm just going to look at my 2 root 2 times 5. A positive times a positive is positive. And I'm going to do my outside. Is that 5 outside or inside?
Outside.
Outside, so 5 times 2 is 10. Does your 2 have anything to multiply with?
No.
There's not another inside. Okay? So I have 10 root 2. Is 2 divisible by a perfect square?
No.
Can't simplify this, so let's drop it down in line with the first term I simplified. Are these like terms? Do the radicals match?
Yeah.
Remember, multiplying has different rules. You can multiply any two radicals together and combine it. Adding and subtracting, you only can add and subtract when the radicals are the same. Here, root 2 and root 10 are not the same, so I am done. Guys, did we do a lot of work in this one problem? Yeah. We had to multiply correctly, not even multiply, we had to distribute, then multiply correctly, then simplify one, then simplify the other, then add them together and not combine them. Is there a lot of places you could make a silly mistake? Yep, check. We are all checking. And my decimals match. Again, just because your decimals match doesn't mean you have the right answer. Square root of 10, not divisible by a perfect square. Square root of 2, not divisible by a perfect square. So that's the other thing I have to look for. Okay? Good? Next one. Type it in your calculator first. Yucky decimal. So I'm going to distribute my root 5 to my 5. So that's root 5 times 5.
Is the answer for the calculator 6.18?
And then root 5 times negative root 5. What's a positive times a negative? Negative. So this is going to be negative root 5 times root 5. Same thing we did last time. I'm going to cover up my second piece and I'm just going to look at the first piece. What can this become? 5 root 5. The only number outside is 5. The only number inside is 5. You always put the outside number before you put the radical. So I would not leave this root 5 times 5. I'm going to write it as 5 root 5. Always put the whole number before the radical. Is 5 divisible by a perfect square? No, 5 is prime, so I'm done with that one. That was pretty easy to simplify. Okay, negative times a positive, like we said, negative. Both of these are under the radical. So what does that become? Root 25, very good. Drop down your negative. What is the square root of 25, guys?
5.
Notice how 25 is on my perfect square list. The square root of 25 is a whole number, 5. The radical goes away because 25 is a perfect square. Drop down your 5 root 5. Are these like terms? Why not? They don't both have a root 5 radical. This has a root 5. This doesn't even have a radical. So I am done.
But can you subtract the 5?
No, because they're not like terms.
Oh.
That would be like saying 5x minus 5 is just x. No, it's not. In order to add and subtract radicals, the radicals must be the same.
Okay.
If you have a whole number, you can never combine a whole number with a radical when you're adding and subtracting.
Okay.
Okay? Then we're going to get our calculator. 5 root 5 minus 5. Same ugly decimal. Good? Are we okay if we only do one more, guys? We're going to skip 9. Let's go to 10. Because then we're going to go to dividing. I need to distribute my 2 root 3 to my 6 root 2. So 2 root 3 times 6 root 2. Then I need to distribute my 2 root 3 to my positive 4 root 3. What is a positive times a positive? So plus 2 root 3 times 4 root 3. Again, let's pretend this is not here. What am I going to do with my 2 root 3 times 6 root 2?
Multiply the whole numbers and multiply the radicals.
So what's it going to become? 12 root 6. 2 times 6 is 12. 3 times 2 is 6. Is 6 divisible by a perfect square? Nope. Not divisible by 4, which is the only number smaller than it. Okay? So we're done with that one. Look over here. What am I going to do? Multiply the coefficients. What's 2 times 4? What? 8. So plus 8. And then 3 times 3 is? So square root 9. Drop down your plus 8. What is the square root of 9, guys?
3.
3. 9 is a perfect square, so notice how there's no radical left. So what does that then become? 24. 8 times 3 is 24. There's no radical there because the only number under the radical is a perfect square. 9 is a perfect square. There's no radical left. Drop down your 12 root 6. Okay. Are these like terms? No. We're done. Now, guys, should we have put this in the calculator to begin with and then check our answer? Yeah, to save a little bit of time, we're not going to do it on that one. We okay? Are we good with multiplying? Multiply the outside, multiply the insides. Done. Simplify. Now, we're going to go to dividing. If you remember from last class, I said you can't have a fraction under the radical, and you also can't have a radical in the denominator. Okay? So, we're going to have to do something that's called rationalizing the denominator. What does that mean? You're going to multiply by a form of 1 to remove the radical from the denominator. Okay? Still, step 1, type it in the calculator. So I'm going to do alpha x to do my square root 7 over square root 2. Type it in with me because, again, some of these are tricky. We've not done a ton of radicals this year. Do alpha x to do your fraction, square root 7 over square root 2. Enter. No. Okay. Before you even try to rationalize the denominator, the 7 and the 2 are both under the radical sign, right? Is 7 divisible by 2? Can you simplify 7 over 2? No. Is 7 a perfect square? Or divisible by a perfect square? Is 2 a perfect square? Is it divisible by a perfect square? No. So there's nothing I can do other than rationalizing the denominator. All those questions we just asked ourselves are stuff you're going to ask yourself every single problem. And if the answer to all of them is no, then we're going to have to rationalize the answer. What is making this an unacceptable answer? Both radicals are simplified. You can't do 7 divided by 2. What's making this an unacceptable answer?
There's giving the radical in the denominator.
So what's making this not a correct answer?
The denominator.
Which is what? Square root 2. So you're going to multiply by square root 2. But if I just multiply the bottom by root 2, that's no longer an equivalent fraction. But if I also multiply the numerator by root 2, anything divided by itself is just what? 1. When you multiply by 1, are you changing things? No. So this is what it means by you're multiplying by a form of 1. This doesn't say 1, but root 2 over root 2 is equivalent to 1. Okay? Are we okay with why we're multiplying by root 2 and not root 7? You're allowed to have a root 7 in the numerator. You're allowed to have a square root in the numerator, just not the denominator. Okay? So, 7 times 2 is, so this becomes root 14. Over 2 times 2 is 4, so root 4.
thought we were going to have a room.
We're not done. Is 14 divisible by a perfect square? The only perfect squares smaller than 14 are 4 and 9. 14 is not divisible by 4, and 14 is not divisible by 9. So I cannot simplify the square root of 14. It stays square root of 14. Over, what's the square root of 4? 2. Okay? Notice when we took the square root of 4, the square root sign goes away. Because when you take the square root of a perfect square, you no longer need the square root sign. Okay? Now, can I do 14 divided by 2 and make it 7? No, why not? 14's under the radical. Is 2 under the radical? No. So are we done? Yes. We don't have a radical in the denominator. There's nothing inside the radicals we can simplify or outside the radicals we can simplify. Go to your calculator, do alpha x, square root of 14 over 2. What makes dividing difficult, guys, is there are so many ways to do this. Okay? And I get the same decimal. Okay? Number 2, or letter B. Okay, we're going to do square root 7 over square root 8. And I don't get a pretty answer, I get an ugly decimal. Okay, can you simplify 7 over 8? Because they're both under the radical, right? So if you could simplify, you would. Are either of those perfect squares? No. Is 7 divisible by a perfect square? No. Is 8 divisible by a perfect square?
Yes.
Yes. So we are going to simplify our perfect square first. So this is going to become square root of 7 over, what is 8 divisible by that's a perfect square? 4. 4 times what gives you 8? 2. Keep it square root 7 over, what's the square root of 4? 2. Square root 2. So once I do that, can I simplify anything now? 7 over 2. The 7's under the radical, the 2's under the radical. Can you simplify that? Nope. Is this an acceptable answer?
No.
No, why not? What is the radical? Root 2. I'm not going to multiply by the whole denominator. I'm allowed to have this 2 out in front in the denominator, right? I'm just not allowed to have the radical. So what I'm going to do is I'm going to multiply by root 2. But if I do that in the denominator, I have to in the numerator. So 7 times 2 is, so root 14 over, 2's the only number outside, root 2 times root 2 becomes root 4. This is still an unacceptable answer because I have a radical in the denominator. Okay? Can you simplify the square root of 14? No, 14 is not divisible by 4 or 9, so I'm going to leave it as square root 14. Over 2 times, what's the square root of 4 become? 2. So this is square root of 14 over, what? 4. 14 and 4 are both divisible by 2. Can I simplify this and divide them both by 2? No, why not? 14 is under the radical, 4 is not. Only the insides can be combined and the outsides can be combined. So we are going to do alpha x, square root of 14 over 4. Same decimal. Guys, I will tell you, next year in geometry, you do this all the time. Okay? You need to know how to divide with radicals. okay? That's why we're going over this now, to help you next year in geometry, okay? Do I think you're going to remember it over the summer? No, but next year, at least whenever your teacher in geometry goes over it, you're not completely lost. Hopefully it's something at some point clicks. You're like, oh yeah, I remember, that's what we did with Miss Hunt. Okay?
So that's why we're doing this for next year.
I'm doing it to help you. Remember, we already finished all of our algebra content. You took your algebra star. So that's why now we're doing stuff that's going to help you next year. Go to your calculator. And I get an ugly decimal. Okay? Now, can I simplify 3 over 2? No. Can I simplify 20 over 4? Yeah. Okay, so I'm going to leave it 3 over 2. Can't simplify that. But 20 and 4 are both under the radical. What's 20 divided by 4? 5. Is that a whole number? So where should that go, in the numerator or denominator?
Numerator.
And it's under the radical.
I guess it's because I think it's numerator because the 20 is bigger than 4, right?
Because it's a whole number. 20 divided by 4 is 5. If you got 1/5, it'd be in the denominator. You can't simplify 3 over 2. Can't simplify the square root of 5 because 5's prime. Is there a radical in the denominator? So did that fix everything?
Yes.
So I don't have to rationalize the denominator here. Just by simplifying the radical, it fixed itself. But we're still going to 3 square root 5, check on our calculator, over 2. So do you see why I'm not always jumping straight to rationalizing the denominator? Sometimes the radical in the denominator will fix itself. Okay? Good? Okay, next one. Go to your calculator. And I get an ugly decimal. The only number outside is a 2. The numbers inside are 2 over 3. Can you simplify 2 over 3?
What do you get for the third?
Look. Can you simplify 2 over 3? Is 2 divisible by a perfect square? Is 3 divisible by a perfect square? So there's no simplifying I can do right here. So I am going to have to rationalize my denominator. What's the issue with this being my answer?
There's a radical in the denominator.
So what is the issue though? Radical, so square root of 3. So what am I going to multiply by? Square root of 3. If you do it to the bottom, you got to do it to the top. So this becomes square root of 6 over 2 square root of 9. Square root of 6 over 2 times square root of 9 is 3. This becomes square root of 6 over 6. Can you simplify the square root of 6? Can you do 6 divided by 6 is 1? This 6 is what? Under the radical. This one's not. Remember, you can't simplify insides with outsides. So we are done. Type it in your calculator to check. Same ugly decimal. Good? Okay, next one. Type it in your calculator. Square root of 81 over 2. Notice this time it's the square root of one whole fraction. And I get a decimal. So, whenever you have the square root of one whole fraction, we're going to separate it into the square root of the numerator over the square root of the denominator. You can separate your fraction. They're both under the radical, so when I separate it into just looking at the numerator and just looking at the denominator, they're both under the radicals. Okay? Well, what is the square root of 81? 9. Very good. Can you simplify the square root of 2? No, 2 is prime. So that's simplified, but is that allowed to be my answer? No. So what am I going to multiply by? Square root 2. So this becomes 9 root 2 over root 4. So this is 9 root 2 over 2. Can you do 9 over 2? Because 9's outside, 2's outside. Can you simplify 9 over 2?
No.
No, it doesn't simplify. Is there a radical in the denominator?
No.
No. Can you simplify square root of 2?
No.
No. We're done. Good? How are we feeling about these? Good? Bad? I will say I think these are the hardest ones. Okay, the fractions are the hardest ones. Go to your calculator, square root of 5 over 18, and we get an ugly decimal. So we're going to separate square root of 5 over square root of 18. Can you simplify the square root of 5? No. Can you simplify the square root of 18? What is 18 divisible by? That's a perfect square.
9.
9. Square root of 9 times what? 2. Square root of 5 equals, what is the square root of 9, guys? 3. Square root 2. So I simplified everything. Is that an acceptable answer? No, you can't have what? The square root of 2. So multiply both the top and bottom by square root of 2. So this becomes what in the numerator? Square root of 10 over 3 square root 4. Is 10 divisible by a perfect square? Nope. So square root 10 over 3 times 2, because the square root of 4 is 2. So I get square root of 10 over 6. Guys, are they sometimes a long process? Yeah, that's why I said I think these are the hardest ones. There's a lot of steps there. Okay? Are you going to have a lot of these on your quiz?
We are? Oh, thank you.
Maybe 4 out of the 20
Thank you.
max. Okay? And some of them are going to be easy, like C was E. If you know to simplify first, it just fixed itself. Okay? Okay, let's look at G. Type it in your calculator. Wah, wah. Ugly decimal. Okay, what is the square root of 4, guys? 2. So the numerator just becomes 2 over. Can you simplify square root of 3? Nope. So what am I going to multiply by? Square root 3. So I get what in the numerator? 2 square root 3. And in the denominator?
9.
10
10 over 9.
square root
Square root 9.
9. So then I get 2 square root 3 over 10 times 3. So I get 2 square root 3 over 30.
Wait.
Are we done? I heard a no. Why is it a no? So you don't know why it's no. The answer is no.
Because you can divide 2 by 30.
2's outside, right?
Yep.
30, sorry, not 13. 2 and 30 are both outside. 2 and 30 are both divisible by what? 2. So 2 divided by 2 becomes 1, and 30 divided by 2 is 15. So this just becomes root 3 over 15.
Can you still put the 1?
Say it one more time, sweetie.
Can you still put the 1?
Yeah. I'm okay if you still have the 1. Definitely type this one in, guys. These are longer, harder problems. Type it in. Good? Last one. I'm going to tell you it doesn't simplify at first. You don't get a whole number. Okay? Just to save us a little bit of time. Okay. 2 over 3. Does 2 over 3 simplify? Does 3 over 6 simplify? Yes. So I'm going to keep this 2 over 3 because the 2 over 3 does not simplify. What are 3 and 6 both divisible by? So this becomes 1 and this becomes 2. What's the square root of 1? 1. Do you need to put a times 1? No, so that basically just goes away. Square root 2 in the bottom. Are you allowed to have a square root of 2 in the bottom? Times root 2 times root 2. So we get 2 root 2 over 3. 2 times 2 is 4. So 2 root 2 over 3. What's the square root of 4? Times 2. Before I do 3 times 2, what do we see?
Excuse me.
There's a 2 in the numerator and a 2 in the denominator. Can I cross out the 2 in the numerator and the 2 in the denominator?
Yeah.
Because they're both outside, right? I couldn't cancel it out with the 2 under the radical. 2 over 2 cancels out. So I'm just left with root 2 over 3. Good? Okay, so we still have 25 minutes left. This is your last homework assignment of the semester, of the year, of Algebra 1. Okay? Please make sure you do it. Each